In this short video, I'm going to walk you through the steps of working with files from Canvas and bringing them into Posit Cloud so that you can make changes to the file, do things like merge, subset, and be able to get the data that you're most interested in looking at from a bioinformatics data set. The first data that we have, which is the merging and subsetting data frames, are going to be these two files about fancy chickens. So we have transcripts and phenotype.csv. Both of these are going to have information about the ensemble identifiers. So this is similar to the number that you had to find for the quiz last week, 1.03. And we're going to be able to put these two pieces of information together using merge and then subset the data to only have rows for one particular phenotype. So I've actually given you the code that you can do this assignment with. This code is isolating only the rows that have the Frizzle phenotype. And you can choose any of the other fancy chicken varieties to be able to do this assignment. So I've already created a blank workspace on Posit Cloud. If you're not sure how to do this, you go to your workspace, new project, RStudio project, and click here to change the name from untitled project to something meaningful. In general, you don't want to have a different workspace for every assignment in this class. It'll just get too messy. So you can do a couple of assignments together that are all related. That's what I've done here and named this Unit 1 merge assignments. I'm going to upload the data, the two files that I just downloaded from Canvas. You can only do one at a time. And once I have both files available in the files folder, I'm going to make a new script. And I'm going to save the script before I make any changes to it. I'm going to call this 1_07. If I called it 1.07, I'd actually run into a problem. It wouldn't be recognized as an R script, and I wouldn't be able to run it. Now that I have that file here, I can go to the example code, copy it, and I can run it in one of two ways. I can highlight a line and hit Control Enter on my keyboard to run one line at a time, or I can use my mouse to highlight the lines of code I want to run and click the Run button. In either case, it's a good idea when I give you example code in an assignment to run it, test it, make sure it works, and you have all the necessary tools and packages installed that you need for the code. And once you can see that it works, you can look at it and see what the output looks like to understand what it did. So we have these two different data frames. One is very simple. It just associates gene with phenotype. The second is a little bit more complicated. It has a lot of other information about the gene. And when we merge them together, we're able to get a wider file. So it's the same number of observations as the larger data set, the My Transcripts, but it is going to have more columns. It's going to have 7 columns as opposed to 6 columns. And what it's doing is it's adding that phenotype description to all the other information that we have about each of these proteins and each of their associated transcripts. Now, the code in the example limits this to one phenotype, Frizzle. For your assignment, you just have to change that one line of code to look for something else. And if I look at the My Merge data frame, I can see there's lots of different choices. So I could do silver feathers, you could do pea comb, so like a funny shaped comb, polydactyly, a blue eggshell. I don't care which of these you pick, just that you pick one. And then you add a line with write.csv at the end of it to write your data frame, whatever you want to call it, to a new file. I'm going to call my new pheno.csv. And this is something that you'll hear me say over and over again in the assignments. Make sure that you set row names equal to false. So what are row names? Well, if I look at any of these previews of my data, I see over here there's a column. It doesn't have a title, where it just has a number. That number corresponds to the row number in the original file. If we want to open this in Excel, that's just going to look like a weird extra column that isn't very useful. So there are times where we'll keep row names, but when they're numbers like this, right, it just is telling us that it was row 18 that it kept. It's not very helpful. So you write that to a file, and then that's what you will be able to pass in on Canvas. If you don't see things like your script that you've saved or files come up, you can just hit refresh on Posit, and usually then it'll show the files. So here's the file that I want, click next to it, and I can export it. Once it's downloaded onto my computer, I can upload it to Canvas. So since I'm going to use the same workspace for the second assignment, I'm going to use the clean sweep button, this broom, to clear all the objects in the workspace, and use the broom icon to clear the console. Now I'm ready to start the next assignment with different data that I'm also going to merge together. So the first file that we're going to merge is a physical file. So I download it and upload it. But the second piece of information that we're going to merge with is actually not going to be a physical file on your computer. It's going to be a search that you do using the Ensembl website. So we visited the Ensembl website for 1.03. Now we're going to programmatically search the Ensembl website using unique identifiers. In this case, they're not ENSD numbers. They're going to be RSIDs. So I'm going to call this 108.r. Going to go to the example script, copy the code. Save it. And now I'm ready to read in the file to a data frame and make a list of only one column in the data frame, a column vector of all the RSIDs. Now I have a list that I can use to do a search on Biomart. Before I'm able to access Biomart, I need to install the library, and I can do that by uncommenting these lines of code. I also put it in the assignment in an easy to copy spot, so you could copy it right from here. But I also have it there, so I just uncommented it. And now while that's running, I can go back here and comment it. And I want to do that for a couple of reasons, but the biggest one is just making sure that I'm not using too much memory on my free Posit account. If every single time you run a script, you reinstall the tools, you'll almost definitely run out of free space. And then you're going to need to pay $5 a month or similar, to be able to use the tool. The loading that package took a little while. I paused the video just while I was loading that up. You know that once you run Library Biomart and it runs without errors, that you have successfully installed the tool. And now we're ready to define which of the Ensembl searches we want to do. So specifically, this is an RSID that is used to identify a single nucleotide polymorphism. So we want to search the SNP mart, and specifically it's a human SNP, so H. sapiens SNP. We can run this command list attributes to look at all the different things that we could possibly search, but you don't really need to do that, just kind of like helping you understand the search. So I'm going to skip that, and then I'm going to run the search. And it takes a little bit, but not as long as loading the library. And what it's doing here is it's taking that list that I made in my RSIDs. You can see values equals my RSIDs. and it's looking up each of them to be able to figure out what are the variables. It looks like it had a runtime error, so I'm just going to rerun this. And it worked the second time. So I think what happened was it just was sort of like a server too busy kind of error. And the second one worked fine. Now we're going to merge. And the data that I'm merging together is the data that I rented from the file, first 100 SNPs, and the data that I downloaded from Ensembl. So the data from Ensembl is really simple. I looked for data using the RSID, and I looked to see if there was a p-value about how certain researchers are that a certain variation is associated with a phenotype. Now I'm going to merge that data with the original data and use it to filter. So I've merged it, and now I can filter for only the very low p-values. You could see when we were looking at the search results, a lot of SNPs, there isn't a published p-value. So we won't look at any of those. And we can tell that we went from 100 SNPs down to only 6. So these are the ones that if I'm really interested in how a genotype leads to a phenotype, those are the ones that I'm going to want to focus on. And my final step is to change the name here. It says what name I want in the assignment, and then just run write.csv to create the file. Again, you may have to refresh to be able to see it, and then you can check the box next to it and export to get it onto your computer and upload it to Canvas. So these merge assignments are very similar. We're really doing the same kind of thing. The first one, you have 2 files. The second one is merging files with search results from the internet. But the idea of Unit 1 is really just to practice loading tools. This tool is a little bit different. It's not coming from tools install packages. It's coming from Bioconductor, which is a repository of packages for R that we're going to use a lot in bioinformatics. And then once you're able to load tools like this, getting data from websites like NCBI and Ensembl directly rather than visiting the website. If you have any questions, feel free to email me, and good luck with week 2 assignments.